I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss perfect squares and difference of squares. We'll begin with the concept of perfect squares, identify trinomials which are perfect squares, and then we'll do factoring. We'll also find the parameter b for a perfect square. And then we'll look into difference of squares and have some communication application questions followed by a combination with four terms. So let's take up the major topic, which is to understand the perfect squares. The formula is given to you right there. X plus minus y whole square is x square plus minus 2xy plus y square. Now, the question for you is to expand and explore the pattern in each of the following. We are given three perfect squares. Question number one, x plus 3 whole square. Question number two, m minus n whole square. And question number three, ax plus b whole square. I would like you to pause the video at this stage, expand, simplify, and then check if these perfect squares match with the given formula. So let's begin with the very first one. We have x plus 3 whole square, which could be written as x plus 3 times x plus 3. Now applying the distributive property, we can expand. Multiplying by x, we get x squared plus 3x. And now multiplying with 3, we get 3x plus 9. Now the center two terms can be combined, and this can be written as x squared plus 6x plus 9. Perfect. Now let's do the next one, which is m minus n whole square. Now if it is m minus n whole square, then how does it work out? Well, that really means that we have to multiply m minus n by itself. So let's do it. M minus n times m minus n. Again, applying the distributive property, we get m squared minus mn. Now with minus n, m minus n minus becomes plus n squared. The center terms here also, both are negative, they get added up. And so what you get is m squared minus 2mn plus n squared. Now let's take the last one here, which is ax plus b whole square. So this can be written as ax plus b times ax plus b. So when you multiply ax with ax, you get a square x square plus axb, plus when you multiply by b, you get axb again and b square. Combining the terms right there in the center, we get a square x square plus 2 times axb plus b square. Now in each case, you can check that you have a perfect square here, right? These two sides, and the center term is twice the numbers which are squared. And that is what our formula is. So all the three expansions actually tell you that if you have an expression which is x plus y whole square, in that case it could be written as x squared plus 2xy plus y square. That is the pattern which we see. Now if it is minus, in that case the center term is minus 2xy. So that is the formula which we are going to use and expand or factor trinomials in such cases. So now let's look into the question 4, which is we need to identify perfect squares. Question number 4 is which of the following is not a perfect square? We are given four options. So let's try to identify. Now the first term here is, let us rewrite and work it out. So we are given x squared minus 6x plus 9. As you can see, x, it is a square. 9 is also a square of 3. And the center term is 2 times 3 times x, right? And therefore, it is a perfect square. It can be written as equal to x minus 3 whole squared. Does it make sense to you? So likewise, you can check for each one of them and then figure out which ones of these are not perfect square. Now let's do the second one, which is 4x squared minus 4x plus 1. As you can see, 4x squared is square of 2x, 1 is square of 1 itself, and the center term could be written as minus 2 times 1 times 2x. So this is also a perfect square. Now let's take the third example, which is x squared plus 2x plus 1. Now x is a square for sure, and then we have 1 as a square of 1 itself, and twice x and 1 will give us the middle term. So this is also a perfect square. Now let us check the last one, which in this case is x squared minus 20x plus 25. Well, 5 squared is 25. We know x squared is x squared minus 2 times 5 times x is what? Well, 2 times 5 times x is not 20, but it is 10x. Since this does not match, we know that this is not a perfect square. So that is how you will systematically eliminate and figure out what the answer is. Now here is question number 5. Now these questions are very popular in tests, so go through them very carefully. We'll soon have a test paper on this. Determine the value of x for the trinomial to be a perfect square. So we need to find the value of k for the trinomial to be a perfect square. So that is k for you. We have two questions here, and in both the questions, k is given to us. Here k is a coefficient of x, here k is a constant term. So let us now try to understand how do we find these answers. So let's go with the first one now, which is we have x squared plus kx plus 100. Now 100 can be written as 10 squared and x squared can be written as x squared. We need the center term, which should be 2 times 10 times x, right? It could be plus or minus, as you have seen. So comparing, what do you get? Comparing, we get k as equal to plus or minus 20. Does it make sense to you? That is how we get our answer. So we can write down k equals to plus minus 20. Now let's do the second one. So I'd like you to now pause the video, perform this operation and figure out what k is. This time k is a constant. So we have x squared minus, we don't know what this k is, but we can always write this as square root of k whole square. This is a very critical step. Center term now can be written as 2 times square root of k times x. Does it make sense to you? So that means 2 times square root of k is equal to 6. And now we can actually divide by 2. So we get k square root is equal to 6 over 2, which is 3. So what is k equals to? Well, we'll square now. So 3 square is 9. So the value of k here is 9. And we get our answer that k in the second case is equal to 9. Does it make sense to you? Not 3. It is 3 square, 9. Perfect. Let's move on and take up the next question, which is factor fully if possible. Now factoring sometimes is not possible. When we are doing factoring, we are looking at integers, okay? So now we have the first question, minus 2t squared. Well, let me make this also as t. 12t minus 18. You need to factor this. You can actually pause the video, factor, and then look into my suggestions. Now let's rewrite this by factoring first minus 2 itself. When you factor minus 2, you get t squared. The signs inside will change. 12 divided by 2 is 6. 6t plus 18 divided by 2 is 9. Now 9 is 3 squared. So that reminds us we could write this as it is already written as 2t square, and this is 3 square, correct? The center term could be written as 2 times 3 times t. That means it is the perfect square. So I could factor and write this as minus 3 times t minus 3 whole square. So that is how we could factor it. Now let's do the next one, which is 4y square minus 28 plus 49. Well, 4y is 2y whole square, that is 4y square. 28 could be written as 2 times. We'll come back to this. First, let's write what 49 is. 49 is 7 square. So we'll write this as 2 times 7 times 2y. Do we get minus 28? 7 times 2 is 14 times 2 is 28. Yes, we do. So that means this is a perfect square and can be written as 2y minus 7 whole square. So that becomes the solution. Let's take up the next question, which is difference of squares. So x plus y times x minus y is x square minus y square. Let us verify this. Okay, so let's do this and verify. So we have x plus y times x minus y. So if you multiply, applying the distributive property, you get x square minus xy. And now with y, when you multiply, you get yx minus y square. Well, xy and minus yx cancel. Perfect. So they can cancel. And therefore, what you're left with is difference of squares of x and y. So we get x square minus y square. So that is a great technique. We can actually factor now difference of squares by moving in this particular direction. So now here we have x square minus 36. We need to factor, think like this, x square minus 6 square, and it can be written as x plus 6 times x minus 6. You're done. That is how you have to do it. Let's take up the next one. We have two more. Very simple. We can write 4x square minus 81. 4x square reminds us of 2x whole square, and 81 is 9 square. That means we can write this as 2x minus 9 times 2x plus 9. 3x square minus 27. So whenever you can group factor, do it. So we'll first factor out 3. So we get x square minus 9. Now 9 is 3 square. So we could write this as x plus 3 times x minus 3. So that is how we are going to factor it. So I hope that is absolutely clear. Let's move on and take the next question, which is factor if possible. X minus 4 whole square minus 16. Well, that is slightly different. Let me rewrite. We have x minus 4 whole square minus 16. Well, 16 is 4 square, so we'll do x minus 4 times 4 square. Now that is difference of squares. Remember, we have x square minus y square. It can be factored as x plus y times x minus y. So we'll do the same thing here. However, now we have x as x minus 4. So let's rewrite this as x minus 4 plus 4, right? This is one term, and the second term will be x minus 4 minus 4. So that is how we are going to factor it. Now we combine the like terms. Minus 4 plus 4 is what? 0. So we'll get just x here, and here we get x minus 8. So that becomes the factored form for this particular example. Question number 11 now. Factor fully. X to the power of 4 minus 1. So let's redo it. X to the power of 4 minus 1. We can write this as x square whole square minus 1 and apply the formula. So we get x square plus 1 times x square minus 1. Now remember, x square minus 1 can be further factored, and therefore we have to continue. It is factored fully, right? X square plus 1 cannot be factored further, but x square minus 1 can be written as x plus 1 times x minus 1. So that becomes your answer. So you have to do it. Now next one here is question number 12, which says application for faster calculations. We need to evaluate 62 times 58. Now, how can we do fast calculations? Well, let's think about it. We have to do 62 times 58. 62 can be written as 60 plus 2 and 58 can be written as 60 minus 2. Well, that is difference of squares. So what we get here as equal to 60 square minus 2 square, which is 3600 minus 4, or 3596, correct? So that becomes our solution. Question number 13 now. Question number 13, communication and application question. Find the area of the region shaded yellow. We are given two squares here. The dimensions of the squares are, the outer square is 2x minus 1 and the inside one is x plus 3. Difference means we need to find area of this yellow portion, which is part of our question. I'd like you to pause the video, answer this question, and then look into my suggestions. So let's find the area and then find the answer. Well, the difference of the two will be area of big square minus area of small square, right? Now, what is the area of big square? Area of big square is 2x minus 1 whole square minus area of small square, which is x plus 3 whole square. Now, at this stage, we can apply the formula, the difference of squares, right? So I hope you remember we have been doing x square minus y square as x plus y times x minus y. So if I do that, in that case we get 2x minus 1 plus x plus 3 as the first factor. The other one will be 2x minus 1 minus x plus 3. So when you expand this, simplify rather, 2x plus x is 3x, minus 1 plus 3 is plus 2. And on this side, 2x minus x is x, minus 1 and minus 3 is minus 4. So basically, we get our factored form, which is 2x plus 2 times x minus 4. So let me rewrite this as the final answer. We could write this as 3x plus 2 times x minus 4. Now that is the utility of difference of squares formula. As you can see here, we really did not expand and then get the answer. But what you could do is, you can always provide the alternate method, which is to expand and simplify, right? I'm not using it, but you can provide alternate method to expand and simplify, right? You should get the same answer. Now let's see the last question of this video, which is extended application, combination with 4 terms. The question here is factor fully if possible. Question number 14. X square minus 6x plus 9 minus y square. Now when there are 4 terms, how do you do it? Well, we can actually combine the 3 and then we can take care of the other also. Let's rewrite and then understand. We have x square minus 6x plus 9 minus y square. Now first 3 terms can form a perfect square, as you can see. So I could write this as x square minus 6x, which is 2 times 3, and this is 3 square, right? Minus y square. So I could write this as equal to x minus 3 whole square. And then we have minus y square. Now we can apply the difference of squares, which is x minus 3 plus y times x minus 3 minus y. It is a good practice to rewrite this as x plus y minus 3 times x minus y minus 3. So I hope that makes sense. That is how you should be doing. So with that, we come to an end of this video. We have seen many examples, and I hope you've understood how we could factor perfect squares and difference of squares. They do have many applications. We'll see most of the applications in the test coming soon. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.